Okay, my name is Philip de Melo, and this is our second lecture. You remember at lecture one, I promised to cover data sources and data types, data structures in the second lecture that I'm going to do now. And I just would like to remind you that lecture first, we just covered a very important material that focuses on the idea of web services and APIs. It is application programming interface. And I told you that web services is the same as application programming interfaces, and application programming interfaces, they can revolutionize public health and public health informatics and technology in particular. It is very important mechanism that will pave the way to fast, very fast data that we are, of course, longing for collection of data and processing of data, because outbreaks and various epidemics and pandemics do not wait that we spend, let's say, months or weeks for programming, for doing other things and so forth. We need real-time processing, real-time collection of data, and API help us a lot. And we are going to talk about it later when I will explain you the so-called file server. What does it mean? And I will demonstrate file server to you so you have chance to work on file server, which is very, very handy. But today we'll talk about data. So the thing is that we have various data and data sources in public health informatics. And it depends on the problems that we are solving, that we need to have data, because public health, as I told you before, the objective of public health is not to cure a patient. It is prevent diseases, prevent outbreaks, to predict and to mitigate different challenges that will face, of course, in the future as well. Now, the thing is that what we have to do to cover today, the major public health sources, and I would say that one of the most important source in public health was, and now is, it is health, it is called EMR, which stands for Electronic Medical Record, and EHR, Electronic Health Record. There is difference between EMR and EHR. We'll discuss it also not today when we talk about very important topic that I'm going to cover with you. It's called CDSS. It is Decision Support Systems. It's a key problem in public health informatics and technology, and we will cover this material. So don't worry about that. So what happens is that before, historically, before EMR and EHR, actually, we had lots of piles of paper with images and so forth, which was very hard to process, impossible to integrate the data. How you integrate paper? To glue them? So you have to be, it was lots of things, inconveniences when you work with paper, because paper get old, it can tear and so forth, you can lose some files. It was a disaster. But with the HITECH Act, so HITECH Act, it is under the HITECH Act, United States Department of Health and Human Resources resolved to spend billions of dollars to promote and expand the adoption of health information technology paperless. So we talk about electronic era that came with the HITECH Act. And of course, the US government spent lots of funds and resources to promote the use of electronic health records. And now it's almost all, I would say not all, but almost all, a great percentage of health-oriented organizations, they use this electronic way to store, to process electronic data. That is very, very important. It is HITECH Act. You can just put it here. HITECH HITECH Act. Okay, so that was the first revolution in public health informatics and technology when we moved away from paper-focused data storage and data processing, we moved to electronic medical records, electronic health records. Okay, this was first revolution. It is very, very important that happened. Now, it is not the thing that we only use these records because each EMR or EHR, it is collection of data related to a single patient. Okay, so we have to process many EMRs and EHRs if we work with populations, but public health doesn't work with a single patient, with populations, so we need to always keep in mind that we will have many EMRs and many EHRs, many records from emergency rooms and so forth, so on. Now, beside that, we have HIE. Okay, so HIE, it is Health Information Exchange. It is a network. We'll talk about it also today. What does it mean? But it is a very, very important source of information for public health. Okay. Number 3, we have claims. So insurance companies receive claims, and the claims contain wealth of information about patients. And sometimes it is indispensable to use these claims, insurance claims. It is a wealth of information. And still we need to use it more and more and more, because when you start working with information claims, you can see that it is enormous. It is a new horizons that we can use as a supplement to HR and HIE. Okay, this is very, very important. And then finally, we have registries. Okay, so registries is a very interesting instrument as well. And registries can be on different levels, on local levels, state levels, federal registries, and so forth, so on. When the companies or organizations who are involved in these registries, they put things together. At some way, it is similar to HIE, but it's not the HIE. There is a difference that we also discovered. I will tell you today. So it is not the same. Okay, so however, what happens that when you solve problems in public health informatics, you find out that these sources are not enough. Although we have lots of data, but it's not enough because it's still incomplete. For instance, in many instances, you need environmental data because we know that environment plays a very important role in expansion of pandemics, for instance. Then we have social determinant of health that gives us information about different communities, how this community is built up. There is a race, income, housing, and many, many other things. So it depends on the problem you solve. Sometimes you can have many different data, and this we call features. I'll just show you on the board. So we call these features. Okay, features. And here we have observations. Okay, sometimes what happens, it depends again on the problem you solve. Sometimes you need many features, okay? And you don't have too many observations. So in this case, your data structure we call wide data, because we have too many features and not many observations. And you have to remember that when you have, let's say, wide data, and you have tall data. Tall data is when you have not too many features, but many observations, okay? Sometimes people say, oh, it is the same. It's not the same thing, okay? And our algorithms processing depend on if you have data wide or you have data tall, okay? And we will discuss it also later on. Now, the data also can be primary and secondary. So what does it mean, primary data? Primary data, suppose you do some epidemiological survey. So you would like to know how many people, how many smokers in, let's say, Prince George County in Maryland. Okay, so you do some survey. And also when we study epidemiology with you, I will explain to you how we should do these experiments, epidemiological experiments. Very, very important. But suppose we know how to do it, and you do epidemiological experiment, you collected a bunch of data, and which is very, very important, we can statistically examine the data, okay, and find out its quality. It is much, much more difficult to do that when you have secondary data. Secondary data is somebody else did it. So because this historic data, sometimes we have secondary data which are 10, 15 years old, okay? And they do not reflect the situation what is now. So for example, they can change, community can change, the income of the community average, for example, can change. The number of men to women can change in 15 years, anything can happen. So you have to use the secondary data with a grain of salt, because you're never sure that you can use secondary data to the current situation, You have no this assurance. But we will evaluate some secondary data. We'll find out whether we can do that and whether we cannot do this, and with what is percentage of accuracy we can expect. So we will also talk about primary and secondary data because it is quite important. So all data we can separate on primary and secondary data. Also, data can be separated in terms of numerical and not numerical, okay, categorical data, we call it. So numerical data is very simple. Suppose you have, let's say, 1, -2, 0, 25. Those are numerical data, yeah? Okay, so that is quite simple, I would say that, okay? Now, what we should understand this also, that numerical data have different types. The first type we call integers. So for instance, here is all integers. I just remind you from school that we have all data integer, for example, integer data. Okay, we have whole data with 0. And natural data, we have 1, 2, 3, 4, 5, we call natural data. Whole data, when we include also 0, right? Now, when we have this data, integer data, it's very important to make their image of in different languages. Why I can say image? Because it is the way we do representation of the data, yeah? So to map this data to have this image. And how to map this in, let's say, Python. I will spend, as I told you, two lectures on Python, and you will know fundamentals of Python. And then we will process with you real public data, and you will use Python. You will never be afraid of large data with thousands of observation or millions of observation and so forth. So in Python, you have, for instance, you don't need now to remember this because we will dedicate the whole lecture on Python. But I will say that suppose you have A, it is our data. For example, you can put here int, it is integer, then it is input, and then you can put, for example, please, it is a string, please insert integer. Okay. And then you will have the window when you run this program, and you have to put, for instance, 15, and A will be 15. It is integer, okay? But if you want to work with a different type of data, for instance, if you want to work with data with decimal points, we call it float. Then A will be, for instance, 15.0. It has decimal after the decimal point. It is float. It is not integer, okay? So this is important, because if you make a mistake in that, sometimes your calculations cannot be accurately done, okay? So this, when you input, it's absolutely important. And if you, for instance, forget just to put input without float or integer, you cannot do any transactions in Python, okay? Now, only strings. Now, what I want to tell you, the third one is called Boolean. Boolean, it is binary. It is 1 or 0. So if, for instance, in integer, you can have infinite number of data from negative infinity to positive infinity. In Boolean, you have only 0 or 1. And this is very important, because all classification in machine learning, for example, binary classification, is we work with Booleans. You have cancer, you don't have cancer, yeah? So Boolean is also important, but it has only two values, 0 and 1. Okay, now, what about formats? And this is quite important. What about formats? Let me just write it down. So data formats. Data formats. Data formats, why play a very important role also? And you have to be sure that you know data formats and you know how to apply data formats in public health informatics. So first, data formats is can be, for instance, applied in terms of Excel. So it has extension XLS, right? So it has rows and it has columns. So this is XLS format, okay? It corresponds to structured data, because data also can be structured. It is this one. Structured data can be presented as table. So we have rows, you have column. It is very, very good when you have this thing. It is much easier to work with structured data. And we will, of course, cover this in all detail. I will explain you how to use structured data in Python. We can do lots of pre-processing, processing, and so forth. Then we have semi-structured data, and unstructured data. So what does it mean? As a structured data, you can always present in terms of rows and columns. Semi-structured data is not necessarily, but it has special label. For example, I give you an example. So suppose you want to invite somebody for your birthday party. Okay, so you send email to, let's say, 100 friends of yours. You send the email, okay, and you can put in email, not all the time, let's say you can, dear John or dear Mary, so it will be different, okay? So emails will be different, okay? And you will get responses different, but they will go under label, my birthday, yeah? So it is semi-structured data, so you have labeled data. And plus you have unstructured data when there is no structure at all. The best example of unstructured data, when you go to a doctor, for example, and he starts writing something on a paper, and then he takes a microphone, start to talk to record this data, plus he sends you for lab, he sends you for X-ray, and all things together. Okay, this is called unstructured data. And unfortunately, we work mostly in public health, informatics, and technology with unstructured data. And it's a big, big challenge how to work with unstructured data and data from different sources. Okay, I will explain you what does it mean, because sometimes students ask me if it is the same thing. It's not the same thing. Okay, when you work with one source, okay, it is the same thing as I have a friend of mine, for example, he comes to our family in his car. It is, let's say, Toyota. Another friend of mine comes in with Ford. So all friends, they come with different vehicles. And in order to analyze, for example, I would like to analyze what transportation they use, I have to see all these cars. You see, the thing is, this is very, very important. So if the analogy is the following, if, for instance, I use EMR or EHR from one hospital, EHR and EMR can be structured completely different from one hospital to another hospital, okay? We will just in a few minutes, I will just explain you what it is, okay? So when we talk about that, it is very, very, it may complicate the whole picture, because we have to be sure and have to be prepared that different organizations, they have different structures, okay? And for example, we used data format, which is called HL7 format. HL7 format, which is also used now, widely used. Many organizations use HL7 format data. They have different versions. One of the most used is called delimiter version. And they have different, for instance, coding. They separate by delimiter like this, and it's not readable. Okay, so HL7 is not readable. But the drawback of that each organization code or may code completely different. So not completely, but partially different. The same thing. So it's same thing. But for instance, I received a letter from a friend of mine in English, and part of this letter written in Chinese. So I have to have a dictionary. I have to spend time. I have to understand even a few sentences, even a few words in Chinese. The same thing what happens with HL7. With HL7, I can receive messages for organization, and they do different coding. Okay, so therefore, it is a time to do standardization, and exactly FHIR is a great step in standardization that we are going to discuss later. We will use it, and we will also compare this old version. It is about 35 years this old of this version, how we can do, let's say, using HL7 and the FHIR, the data exchange. Okay, so what we have now is we have Excel, and also we have a very widely used, we have C, comma, separated value. For example, 1, 3, 5, -6, John, Mary, -300. This is common separated value, okay? And we can always try to, for example, to put things in the same basket. So in other words, we try, for example, to transfer, if it's possible, and CSV, it is quite easily to transfer to Excel, for example. Since we're going to work with Python, it is very, and I recommend my students, it is a very important and very useful format in Python, which is called pandas info data package. So Python has a specific format that we can take our data and transfer to this. Why it is? Because after that, we can use very rich Python libraries in a format in pandas way. So this is another format, and we try to put our data in this format in order to use libraries. And I will show you how to do it. It's very easy. Okay, but this format is important. And then you remember I showed you Postman in lecture 1, and I asked you to send to Google some request and to receive with Postman response. And you received response in Postman, and some of your students sent me messages, which is absolutely correct. They received messages from Google in terms of HTML. Okay, this is language they used in different web sites. Okay, and since we send to Google to find websites with information about viruses, Google send us data in this format. It is HTML, it is for web sites, okay? However, in public health informatics and technology, also a very important format, it's called XML and JSON. So these two formats are very, very important. And from, let's say, my experience, I would say that I use XML when I have data, when I have a document, I would like to have it very concise, short. So this is XML is wonderful way to represent the data set to make it short, okay? So it is in some way it becomes like a wide data, but it's not the same. I will explain to you too. But if you have, let's say, a large data set and you don't care much about to make it short, the best thing to use JSON. Why? Because web browser can read it. So web browser does not read HL7. So web browser cannot read HL7. Okay, therefore HL7 cannot be used for fast exchange, data exchange, for fast interoperability. HL7 cannot be used. Okay, so we use the JSON, we use Fire API, and we use the API in terms of REST, because XML, if you want to use API, you can use it. It's called SOAP. SOAP API uses only XML. Okay, but if you want that your browser reads fast the document that you're going to send, JSON is the best option. So this is a golden rule that I put for myself. So if you have a complex document, okay, you want to make it concise, you can use XML, very official, nice, but it's not well readable by web browser. It is best thing is to use JSON. And we will also talk about this JSON, and we compare XML, we can compare JSON and the HL7. We'll see these formats, how they look like. Okay, now I would like to show you the electronic health records, how it works. And I would like to share my screen. And I would like to show you the electronic health records. Okay, so it is my share screen. Okay. Okay. So this is electronic health record. Okay. So how it works. Now, so what does it mean? Here is a menu at the left-hand side. It is dashboard. It is messaging. In messaging, you can send just messages to your healthcare provider. He can or she can answer you. Okay, somebody can schedule appointment, for example, administrator who has access to this EHR. And there is a billing, so saying that how much you owe or this insurance paid and so forth. And you have different patients. And for different patients, we have specific the EHR and EMR. Okay, this is just a dashboard, okay? And each provider has this one who is working with EHR. So I just put my name as a provider. Now we have here reporting, we have modules, we have tools, but we'll talk about this, let's say patients, and I will explain you how it works. So here is you have to put on patients, you have to put patient search. Okay, and here it is first name, middle name, last name. I just invented this person with these numbers and tools and tests maybe doesn't exist. It is just I invented this. Okay, and here is I see here Lisa Andrews. Okay, I repeat this. It is just fantasy. Okay, so let me just see what it is. Okay, so first of all, we have various, so we have dashboard for this person, okay? And in order for us to start a new appointment, do not forget to put here a new message. This is very, very important. When you put new message, you start a new appointment. And then I'm not going to go there because otherwise it'll take lots of time. But here is we have let's say e-prescribing, because I can using EHR I can do as a health care provider I can prescribe medication for her. Okay, then I have to do, let's say, scheduling here. Okay, I can put this calendar, I can put this appointment, and so forth. Then we have here let's say work list. Okay, this is all notes. When you finish this appointment, it will automatically will say you finish note. So that is all notes that all appointments she had. Now we can find out, for example, in the dashboard, we can go here. This is appointments. Okay, just a second. This is appointments. And suppose we have here also we can see here various things. For example, just a second, I can find you. Yeah, so for example, we can have here various documents, for example, history forms, imaging results. For example, we have lab results here. Let's see now what she has. So these results we have. Yes, so we have, she had here EKG. We are not doctors, so we are not supposed to do any analysis of these results. We are just informaticians. Informaticians require to be sure that everything is in order. Okay, so and another thing which is very important, I will just say you in a second. Here we have, for example, medical X-rays analysis of Lisa. Then we have here another result. This is, I think it is blood test. Okay, it is very easy to upload. You can just use this uploading this one to upload. You see that upload. And for example, if you work for a hospital, you can upload in electronic health records anything you want using just this symbol, and you put in this area of different tests. Yeah, so you can upload all kind of tests for Lisa. So this is also kind of test. I don't know what it was. I'm not a doctor. Okay, and we have here other forms. We have results here. Okay, many things. Then we have here also, just a second, we have here, for instance, we have patient information. It is Lisa. That is it's here is provider. It is address of Lisa and so forth. So if, for instance, I would like to send this data to somebody else, so they will not receive this one because I will send something anonymous way to be sure that there is no any problems with security and privacy. So we have this patient demographic. So she is African American. Her language is English. She's a school teacher, and she works full time. Then it is her telephone number. Of course, it is all kind of fantasy. It is voice phone. Okay, then it is we have different things. For example, here as just a second. Yes, we had here. Yes, authorized representative. Okay, and we have here, for example, important allergies. So allergies, she has allergy. Why I said this important? Because you see, suppose she has this healthcare provider, and she comes for appointment, and imagine that this doctor doesn't use electronic health records. So he has to go to pick up her file. He has to find what kind of allergy she has, and he finds that there is this page is missing. And finally, it is a possibility he or she will prescribe her medication that she's allergic of. Okay, so for example, she cannot take aspirin. So this electronic health record also they have inside the so-called, and I will explain to you when we will start the decision support system, that it has decision support system that will prevent the errors. It's number one. Okay, so it will say the doctor that you prescribe the aspirin, but she has, for example, very few platelets in blood. So if you prescribe aspirin, she can have problems, because she'll have internal bleeding, for example. So I'm not a doctor. But this decision support system gives a message to the doctor that he makes a mistake and he oversaw this allergy. So same thing, we can have immunization records, for example, if she has or not. Then she has here vitals. It is important to get. So, and also it's very, very important, and I'll tell you now, that decision support also shows a doctor, because a doctor cannot look at, she might have maybe 100 of different results, 100 of different images, and so forth. So in this case, a doctor cannot see it right away within, let's say, second. And the decision support system also gives a message to a doctor that he has to look at, for example, some analysis that may be abnormal and so forth. So this is a very important decision support system, because without decision support system, electronic health records only play a role of convenience. Instead of paper, we put everything here. But here is a very strong instrument. And I believe that with the years to come, a decision support system will become the most important element in electronic health records, besides data, of course. Yeah? So they'll be very, very important. So what I would like to show you something is the following. If I go back to the images, okay, so for example, image results. Let's say I take this one. Okay, this is X-rays. Okay, see the decision support platform. This decision support platform uses artificial intelligence. So using artificial intelligence is very wise in electronic health records. Why? Because you know that, for instance, if you play chess and you can be very good in chess, for instance, I like to play chess, but I can never compete with computer. It is impossible. I never win. So same thing is here. So it gives you lots of information. It's a winning situation for our informatics because it shows some features. I'm not a doctor, I don't know what it is, but it shows some features that are not seen in the conventional, let's say, X-rays. Yeah. So that is also very important because it's a great step ahead to uncover things that a human eye cannot see, but the computer can see, and ask the health provider, take a look. So the decision support system does not substitute a doctor, but it just helps doctor making decision. That's what it is. So it doesn't substitute, but this is very important. So what I would like to tell you now is what does it mean, HIE. I will just disconnect my, just a second, I will just disconnect this thing. Okay. Yes, okay. So let's just talk about HIE. HIE, it is health information exchange, and HIE, health information exchange. And we will talk about it in more detail when we talk about the interoperability, health information exchange. And this can be viewed as a network. So network, it has a nucleus. So it has common data repository. We will talk also the whole lecture. I will devote, I will explain to you what does it mean data repository in public health, because it is also important. And we have a variety of data repositories. We can have data warehouses, data lakes, data lake houses, and so forth. Okay, and the connection with the data. Okay, we can also cover this topic. But if you have common data warehouse, okay, then you have some connectivity, because network has connectivity with various organizations who share data with this repository. It can be lab, it can be a health, it can be a hospital, can be a private clinic, it can be, for example, radiology department, it can be, for example, a non-health organization. Okay, so we have different um, sources for HIE, health information exchange. And what happens is that it is important. Why it plays a so important role? I will tell you why. So suppose we have a patient and he comes to ER, emergency room, and this person, unfortunately, in a critical, it is critical situation, very abnormal, and he cannot even talk. Okay, so how we can know what his problems, what his allergies, what his this and that, and we don't know that, So doctor can only guess, and how he will guess, This is, we need to act very fast because this emergency room. So the doctor sends a message to this HI, electronic health information exchange, and health information exchange need only name of this person. So he takes a look at his driver's license, for example. So it's not necessary to talk to him, and he will get right away all answers. So this person, what his problems, he will have all full picture of that with his allergies, so he can prescribe medications. Maybe he cannot stand surgery. He has to have some other cure. So he will get everything from HI. It is only one element, and we'll discuss what other benefits of this network, which we call a health information exchange. It's very, very important. We will talk about it later. And finally, I would like to talk about a little bit about registries. Registries are very important too, and registries are specific because HIE is not specific. There can be can be, for example, patients with cancer, with cardiac disease, normal, but they turn to ER some way, sometime. So some people, they might have other diseases, like chronic diseases. So it is like a smorgasbord. It's everything in there, HIE. Okay, and we will also discuss, by the way, which is the best data repository for HIE. We'll discuss it later also. What happens here that registry is very specific. For example, we have registries for cancer patients, we have registries for some Parkinson disease, and there's so many registries. And also, I would like to say that it is also a challenge to work with registries because they are structured in different ways. There are different data in there, and it is a lots of work for us data scientists working with registries. And plus, there is a lots of data. I will just give you a number. You won't believe me. There is a registry which also is called, it is called NSSP. NSSP. It is a very famous, so all data scientists know this. NSSP. So this is works with it works with together in conjunction with CDC. Okay. And they have the, federal partners, local, state health department, and so forth. You cannot imagine, they receive 8 million EHRs a day. 8 million they have a day EHRs. It's unbelievable. So therefore, it is very important for us and to have a specific workforce that is able to work with registries. Okay, and also I will teach you to do that. When we have lots of data coming with, let's say, high velocity, 8 million EHRs a day, it's high velocity per day. Okay, we can see how many EHR comes per minute or per second. Okay, this is a big number. And if you don't have professional people who know how to work, it is absolutely useless for this country public health informatics and technology, because they will not be able to help solve problems that we have now. They won't be able to solve problems with let's say maybe upcoming challenges, pandemics, the different outbreaks, and so forth, because they have no idea how to work with this data. Yeah, so I will teach you this too. Now, finally, I would like to say that I would like to finish today because I don't want to overload you, because you received lots of information. So we will talk next time. Lecture 3, we will discuss the data repositories, how to collect the data, how to store the data. And also I will teach you, we will just brush up a little bit statistics, because it's very important how we can handle primary data and secondary data to evaluate the quality of data using statistical analysis, and also how to work with different sources, how to integrate the data using statistical method. We will discuss it next time. Okay, thank you for your attention. Bye-bye.